we are having some yield
Got it.
issues below like 3 nanometer. So
No,
I think that's why like
currently the
most
most
of the
lowest
projects got
nanometer
cancelled also.
available in the market is, I got it.
Uh,
Like most of the
Intel.
nearest to that, if you ask me, the most lowest nanometer is 1.4, in which Intel is working. Like currently, projects are
Uh,
going across the industry in 1.4 nanometer.
1.4, 18 angstroms, right? 18 angstroms also going, right?
18 Armstrong is a different. So 1.4, I think that's technology. That name
Mm-hmm.
is 1 2. I think they are naming their
Okay,
PDK as
okay. One, two,
1276. That is
yeah,
actually
1205.
7
Yes,
nanometer.
yes.
1 to
Mm-hmm.
7 at as, yeah, 1 to 7 8 as 5 nanometer, and that
Mm-hmm.
1.4, I'm not remembering what, 1 to 880 or 85 something. I'm not remembering that node level, that name actually.
Mm-hmm.
That's the code name of the PDK actually. They make it.
Yes, yes. Yeah, yeah. Yes, yes.
So there are lot to learn in the analog layout.
True, true.
Because actually,
I agree. Like,
till
yes,
now
yes.
I am learning. Till now I also
Yes,
learned
yes. So,
many things
how
because
many experience you are having?
technology is
Sorry.
drastically changing.
Yeah, yeah. Since how long you are doing like
Like
analog
I
layout? Like,
like from 11 years I am doing, so I have to
okay,
have
okay,
11 years of
okay, okay,
experience.
okay, okay, okay. Yeah,
So
it will be
I'm
even
into
if you are
this
having this
industry
much
a
also.
long.
Yes, 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 yes. Like, still there will be a lot to learn actually.
Like, see, after this one, like after 11 years of experience, like you are in some around managerial position, okay, or senior lead engineer.
Mm-hmm.
After this
Yes,
is
yes.
not, you will not get the hands-on exposure to the layout directly. You will be
True,
on
true.
the managerial level directly, where you will managing a big team. Where
Yes, yes.
I last managed the team in which last I worked on when I was like 10 rough around experience. Like after that, when I was only
Mm-hmm.
managing the team, there are a lot of contractors working in under us actually. Under me, there are like a big
Mm-hmm.
team, or there are lots of contractors from third party companies coming working here.
Yes, yes,
So we
yes,
have to
yes.
manage them actually.
Okay,
So
okay, okay.
tool thing you will lose if you are like if you are very techie guy, like you want to work over tool, many things you want to
Mm-hmm.
know, you will not get at the managerial
Yes, yes,
positions.
yes, yes. I agree. Yes,
They have to do their sitting arrangement, work from home arrangement. These all things you have to take care. Then you have to approve
true,
their
true.
timesheets. These are the things only
Yeah,
manager you
yeah,
will be
yes,
doing
yes.
there.
Yeah,
Nothing
yeah,
else.
yeah. Yes, yes.
So up till maximum 8 10 years, you will be maximally working on the layout directly. After that, you will be going to
Mm-hmm.
managerial positions.
Yes, yes, yes,
There is
yes.
no
Even
use of
in
layout.
circuit design
Only
also,
knowledge is
until like
required.
exactly until in the circuit design also up to until like 12 years we'll be working on hands-on. After that also we need to do like mostly managerial kind of things only will be there.
That's a complete different story. So
Mm-hmm.
till we are getting like able to work, so you should be working in the tool because tool
Yes, yes,
exposure is required much.
yes, 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 yes. Agree, agree. Yes.
So many things, because see, drastically technology is changing. Planar, then FinFET, then now GAFET is there, like gate all around. So like these
Mm-hmm.
are the technologies changing. So we is actually changing the layout fundamentals also at some level.
Mm-hmm.
Ribbon fat is also coming.
Okay, let's start. So Ribbon FET is the GAFET only. It is Intel's rebranded name of GAFET.
Mm-hmm.
Sir, how to remember
Gate all
concepts for
around FET,
long
if you
time?
see, only practice. A tool only you have to do. Only about the it's a lot to remember the concepts. Like definition wise, to tell you have to read the definitions. But if once it is like in class 12, you are not no longer using them currently. Like we are not using longer doing hands-on or doing like in pen and paper. We are not doing Young's double slit experiment, all these things. But we know what the things are, some around that one. We know how to use them actually. So when require again to learn, we will just read the fundamentals. It will get clear. So only practice can make you clear all these things,
Okay.
right? Okay, Mahesh, let's start the class.
Yeah,
If
yeah,
we
yeah.
start discussing, there are
Yes,
a
yes.
lot to
Yeah, it will.
discuss.
Yes, yes, agree.
Actually, Intel rebranded the name of GAA
Mm-hmm.
FET to Ribbon FET actually, with some major changes, but some minor changes. They renamed it actually. Nothing else they did.
Yes, yes. These are like marketing gimmicks.
Intel is struggling
Yeah,
right now,
marketing,
actually.
nothing else.
Yeah, yeah.
That company, that is industries. What I can. That's behavior. It happens. Today, Intel is there. Tomorrow, Nvidia will there. Some other company will there. Okay, so we ended up with tri-state inverter in last class. We did the tri-state inverter. Some actually requested to do the tri-state inverter for him. So we did the tri-state inverter actually here. And so last I will be doing one layout, last layout. So like 2, 3 guys have joined later. So for them only, I'm just doing a last layout. From next week, I will like this week we should have started the fabrication, but some guys joined late, and one request was there for the tri-state inverter. We did a tri-state inverter, and now we are all working in this last this layout I will be doing. Then we will be ending up this layout thing for the tool famulation. Then we will again work in the layout in the time of analog layout concept. In between, there will be CMOS fabrication basics, all sort of thing we will be discussing. Okay, so before going, we'll uh, let's start with this one. So let's start with the 1 second. Yeah, you guys are ready with the tomorrow's exam. Hello, everyone. Like Sandhya, Pratusha, Arshad. Hello, hello, Arshad.
Yes, yes,
Sandhya,
sir. Hello, sir.
Pratusha. Are you guys ready with the tomorrow's
Yeah, sir.
exam? 12
Yeah,
p.m.
sir. I will do my best. Yeah, sir.
Okay. See, like any help if required, you can just like ask. Okay. You can, if any help required before the exam, you can ask me. Okay. Not in the time of exam, because in the time of exam, if you ask, they might get no. So like you have to face the interview directly. So before exam, any questions you can ask. Okay. So last I will be do the mux, 2:1 mux, in which we have two AND gate, one OR gate, and one inverter. Okay, we will be doing this one and we'll ending up this thing. Okay, let's do it. Mux. Excuse me. Okay, so we need uh what we need. We need some couple of things like for this one we need two AND gates. Okay, because AND gate we don't have, we only have the NAND gates available. So what we will doing, we will making this NAND gate, we'll converting this NAND gate to AND gate using an inverter. So actually here one inverter is there. We need more three inverters. One, two, three. Two for these AND gates, to convert them to to for to convert the AND gate, and NOR gate is that will convert into OR gate. Okay, three extra inverters are required. So in that case, we will be requiring NOR gate here. One NOR gate should be here. Gates 1 and 2 should be here. Like who's that? And inverter. And inverter. 1, 2,
Then I'm
3,
unable.
and a 4.
Yes, no, it's,
Yeah, what happened?
sorry,
Hello?
sir. The screen was lagging. It's okay now.
Okay. So sometimes it happens. It's actually my issue. You need to blame Bill Gates for this Tenadela for this one. Why they are not fixing these bugs actually in Microsoft Teams. So we will be first creating these things actually. This is now converted to AND gate. Now we will be connecting as per the schematics. So it is converted to a OR gate as well. Then we and like we will be connecting this to them, and like as it will be connected to this device B part. Okay, B part it should be connected. So let me connect it here, and then its input should be connected to the B of the second one. Okay, and then it should be connected to the B of the second one. This should be okay, and from here for this one it should be go to as a select line. It should be going as a select line up till here. Okay, 1 second. It should be going as a select line from this end. Okay, then as a select line it is coming. Then A and A are I0 and I1 available as a I0 and I1. Let me put it somewhere here only. Let me put it somewhere here only and here only. Okay, it should be now fine. Let me put it as a I0. I0 as a input. Let me make it as a I0. Okay. Then I1. This should be as a I1. Okay. I1. I1. Okay. And then this should be as a select line. That is a select line. That is it should be a select line. Okay. After this comes up till here, it is already available. We will just put the output here. Okay, we will put the output here. It should be Y actually. Okay, it should be Y. It should be Y. Then we will be putting this one as VDD lines to them actually. VDD lines to them. I can separately put pins in this area, but that will take time for me to do. That's the reason. Actually, that is much more cleaner. That will be look much more clean. Actually, that layout with that schematic design will be, but it will take a lot of time for me to complete. That's why design I am doing it like this. Actually, in industry, what we don't do like this kind of routings, like this kind of wirings. We don't do. We just put the uh, VDD one everywhere we will put, and it will automatically get connected internally. Okay. Now this area, what we will be doing, we will be just connecting them to this area to this area. We will be start connecting them from here to here. Okay, and then this should be also be connected. And let me connect them proper. Okay, let me connect them from here directly. I can directly connect them from at this level. I can directly connect them from this level to this level. It should be connected like this. So if I'm not wrong, okay, this got left actually. It is left. We can
Sir,
short it here only. Yeah, hello. Who's this?
sir, I am Arshad, sir.
Yeah, tell Arshad.
Sir, we can leave it. We can leave it like that only, sir. VDD and VSS lines without giving connections.
Like how you will leave? You cannot leave these ports open. You should have a point to connect every one of them. Either you connect in a single line and then put VDD, or you can put VDD for each of them. Each of them, it should be get connected internally. So like yeah, normally you cannot leave them actually. It will actually for the below hierarchy it's fine, but what is that pin is connected? It should be declared actually. It should be actually declared in for what purpose those pins are actually. That should be actually declared, na? Hello?
Yes, sir. Sir. For
That
small
should be
circuit,
actually
it is fine, sir.
for any like any circuits when you are putting, you should be declaring those pins. If you don't declare, it will not pass the extraction actually. It will not pass the extraction. It should be declared actually. So like when I'm saving it, it should actually declare. See, it is giving error in this NOR gate. In this NAND
No,
gate
sir.
also it is giving.
Instead of connecting the single line, we can give for each device like VDD pin, no, sir, by giving way.
Like I'm not getting what trying to say. What you're trying to say? Hello? Hello?
Is
I0. I think some error related to the internal coming. Pin name collide with instance name I0. We can mark a schematic. Pin name collide with instance name. Okay, let me check the instance. What the instance name coming here? What is this instance name? Okay. Might be that's the reason I0 and I1. Instance name, like make it as a uh, I1 like this only. Let me rename it. Let me rename this as a I2. Might be the reason that it is actually highlighting I3. Let me make it I3. And then let me make it as a I5. Then this, let me make it as a I4. Sorry. I0. And this, let me make it as a I6. And like two warnings are there. Where are these two warnings? Warning pin out on I0. I think this should be the I0. Okay. Out on instance I0 floating input. Pin our pin in on instance I6. So, okay, out. Okay, like actually, let me check this guy. I think it is coming from the below level. Okay, I think actually it is coming from the below level, not this level actually. And pin I6. Uh, where is I6 actually? Let me check the I6 from here. Okay. Then it says I6 floating point input in I6 and floating point, floating input. Actually, I think it is coming error from the below hierarchies. I think actually it is coming from some below hierarchy actually. Okay, we'll see that one later. We'll go to Excel now. We can log like see we can create the schematics like this. So this is how we can create the schematic. If you see, this is the mux schematic in which two AND gate, one OR gate, and one inverter was there. Okay, but we don't have AND gate devices available. We didn't build that AND gate. We can build it and make it instantiate here. That's fine. In that one also there will be two NAND gate, one NAND gate and one inverter only. One NAND gate and one inverter will be only there in that AND gate device only. So, but we didn't created that one separately. We just instantiated them here only. Okay. Now, if you see here, you will be able to see that there are more three instances available. One, two, three. Three inverters. Those are like one, two, three. This area is being. This area it is becoming like when you will be getting schematic in the industries, it will be looking like this one. Let me show you guys once. Okay, like who are actually experienced, they will be knowing that one. So who are not experienced, they need to know this one actually, like how it looks actually in the, like when you get the schematics in the industry, how it should look like actually. Okay, how it should look like, should be knowing that one. What happens, it let me name it as a rectangle like this. Okay, just I'm trying to say that one. Okay, like this one will be drawn and it will be given as a NAND gate. Suppose it is when been drawn here and okay, what happened? This one, one second.
Sir,
Note.
one question.
Yes, still.
Why you change the instance name from, for example, from capital I to small I?
Like who's this?
Rahul.
Yeah, that one I changed actually because the reason was in that one was actually it was not passing. What is happening now? There is I0 and I1 in this one. There is I0 and
Mhm.
I1 in this one. See here, I0 and I1 the input name is available. It is matching with the instance name. That is the reason actually I have to change that name.
Okay.
The input name I0, I1 that is matching with the instance name actually. That is the reason why I actually changed it.
Okay, got it, got it.
Okay. Shape rectangle. Like 1 second. We're just creating what's that? Okay, we are trying to just create, because in industry when you go, you will able to see this kind of actually, you will able to see this kind of parameters will be written on this one. Like let me show you. You have to go to create. You do not need to do all these things. It is the part of a schematic engineer. They will actually take care of these things. Okay, so initial rectangle like these things will be there, and it will be written here that this area is your AND gate. Okay, and here it will be written as note, like it will text will be written uh, AND the AND gate. In this one, in well, like let me show you. Uh, in AND plus not, let's say, or like INV. Okay, it will be written here like this. It will be written here like this. Okay, and you have to get, so like it's a very generic thing. It's a very easy in such a low level schematic. It will not be written. But when you will go to the big schematics where matching will be there and shielding parts will be there, there it will be for sure. It will be written for you. Like AND gate, NAND plus inverter, it has been created. Then like for this one, you will be seeing like this. You will be able to see in this one. Sorry, in this one you will able to see here. You will able to see like this in this one also. It is written in this way. It will be written here as text. Like it should be written as a OR gate. Okay, or gate, like it should be written as NOR plus INV. Okay, NOR plus INV it is. Just it will put
By
on this
mistake we
one.
wrote not.
So which one? Oh, okay. Oh, sorry. Okay, let me write it again. Like NOR sorry, plus invert, like it should be a OR gate actually, OR gate. It should be like NOR plus INV, NOR plus INV it should be, and will so which will give you a idea that this is the device area. Like this should be in industry, it will be given like this only. The schematics looks very professional in the industry. Okay, it will given properly to you, in which you will able to see those diagrams properly. And let me it will be not much actually will available. So many things will be written properly in those you have to follow, like in the like constraints. What is constraint, if you ask me? In the when you get the schematic like this, when you will open the schematic like this only, with the first in the schematic you have to know which are the critical blocks. You will get to know later stages when you will it will come which are critical blocks, which are the digital blocks. You should be knowing those things. You have to note it down in a copy that these are the critical blocks I have, these are digital blocks I have, at some excuse me, in this one side by side, or in the top bottom, or in the top of the schematic, constraints will be written. Like for these devices, this number of dummies are required. So for these devices, this is the matching pattern I require. For this be requiring shieldings, which are shielding. Like suppose if this kind of symbol, like let me show you, like when this kind of symbol, if it is given, suppose let me show you, suppose a symbol is given like this. So this kind of, suppose let me show you like this only, it should be like this only. Okay, should be like this only. Suppose any diagram is given like this on top of the schematic like this, you should be knowing that this, and it will be written as coaxial or sidewall. Then you should be knowing that this particular input signal should be shielded actually. It should be, what is shielding I will tell later. Like actually it should be shielded either like this kind of box will be given, or double sided, like one drawing here and one drawing in the below, it will be line will draw. Mean this signal should be shielded, and it will be written as to which signal this should be shielded. And you should be knowing, generally we do in ground, and the shielding we do in ground or with the power one. So knowing that one, for which particular net actually it should be connected the shielding lines. So it will be written there actually properly. This should be written that you should be following those guidelines to start the layout actually, and should be writing those things, that these signals, okay, this signal should be shielded. What shielding? This shielding. This is the matchings patterns required. So common centered matching. Inside you have to draw your common centered matching in your pen and paper only. Then you should be implementing there. What is the pattern you are using? Then what are the critical blocks you should be knowing. So these are the major steps you should be knowing before going to a layout part. So all these constraints or the information will be provided over this black screen, over the schematic only, and a and some kind of Excel sheet or note, one note will be also there. In those things also, these constraints will be written down. So from there also you should be reading and knowing those constant things. Then you should be touching the layout. Before not knowing, if you're not knowing, you're confused, you should be asking. Before not knowing, you should not be asked, you should not be go to the layout actually. If you are done the layout and it is cancelled, then it's a very hectic task it will become for you. Okay. To the layout. So this our schematic is ready. Now we will go to the layout. Okay. We'll simply go to the layout, that marks. Okay. We are in this layout editor window. 1 second. I'm later in the window here. Press E and let me get 0.005 and then 0.005 here. Okay. It is done here. Everything done. Okay. I will do 1 second. I have done up till here. Now what I will do, grid pattern set. Now I will go to all generate all from source. I will go to IO pins first. And I will change this whole thing and select the whole thing. And I will change it to metal 1 pin once. One second, who's that? Okay, I will be changing to metal 1 pin, this one. Changing this to metal 1 pin and update it. It will should change to metal 1 pin. Then click on create a label as option, same as pin, same as pin. Okay, and this I will make it to Roma. You can do it this one later also. I am doing it now only. This one later also. It's not a big issue. Okay. And all thing done. And then simply press OK. If you press OK, you will be getting this type of things. Okay. You will getting this type of things, which is actually your layout. This is your PR boundary. This is a couple of layout blocks which we are using. If you press Shift plus F in the cadence bind key PDF or hotkey PDF, this all informations are given. Just press Shift F to turn on the layers, Control F to turn off the layers. I'm just pressing Shift F. When I'm pressing Shift F, I will be able to get this layout. So these are the pre-built blocks. We have already built these layouts actually earlier. We have created these layouts earlier, so we will able to use these layouts now actually. Okay, we'll be able to use these layouts now. So these layouts are completely pre-built from the scratch. We will be able to use them. Let me give me 1 second. I think this NOR gate has been switched back to the older version. Let me go to that one once and let me change this one first. 5 and should be 0.005. Let me fix this one once. Okay, let me fix this guy. Okay. And let me align this one with this guy actually. Why it is like this? Oh, okay. Okay, this side also, okay. This side also be aligned with this one. Now this should be looking fine. Okay. And in this case, let me let me 1 second, please. Let me align this one. I think some error happened. Let me fix it. Give me 1 second. I'm fixing them. Let me fix them immediately. Okay. Let me fix them properly. I don't know what happened to this layout. Give me 1 second. Okay. Okay. Like 1 second. Give me 1 second. Let me just fix them actually. Actually, it moved from this side to that side. Okay, it should be inside this one only. Let me check this. Okay, this should be fine for this part actually. And then, okay, they are left out. Okay, let me fix them once. Align them with this guy. Okay, and let me align them. Sorry for this one. Actually, it should have been fixed earlier only, but I don't know why we missed it. Not an issue. We'll able to solve it. Okay, okay. Let me take it down somewhere here. Okay, let me pull this one down up till this level. Let me delete this guy. Okay, let me delete it up till here. Okay, and then for this one also it's fine. This one also it's fine. Everywhere they are fine actually. Okay, now also done properly. So there should be actually a minimum distance of 0.12. That's fine
Sir.
here. Yeah, tell, Arshad.
Sir, do you fix grid value, sir?
Yeah, already I fixed the grid value, na? 0.005. I fixed it. But one question, like how this one got missed, man? This should not have been missed, right? This should have been, it's a NOR gate, right? So if it is a NOR gate, source is going there. Okay, so How we are missing this one? Then what is this net actually? Huh? What is this net, man? Let me check this net once.
This will also be source goes to VSS, the last one.
VSS? Okay, okay, yeah. That's a parallel, right? The parallel layer. Right, na? Parallel that one. Thanks,
Yeah.
Uzair. Thanks for that one. That's a parallel thing. I thought this is an AND gate only, and I was searching for that one, and I was searching for that one only. Okay, yeah, good, very good. This should be go to source here, and this should be fine. This should be connected properly. Okay, all done. Okay, I think this should. It is now fine to go with this one. We'll be able to do. And let me switch back to them. Shift B, and let me switch back to this level. Okay. Okay, I think it is already done. Let me go to switch back to Excel once. I think I can use this one now. Okay. Now I have to just fix this one, so it is not a big issue. Just we have fixed them already. This all fixed properly. Now what I will be doing, I will be simply putting these values as per the scheme. Sorry, what is the schematic actually? Okay, this is the not required. This is the mux one, the NOR gate one. Let me do one thing. Let me divide this screen to two parts. It will be better to use like this. Let me divide the screen to two parts. Let me make it a bigger screen actually, and let me divide them into two parts. And then okay, now we should be able to do. Okay, first start with these devices. Okay, we'll start placing first this device because these have the inputs actually. If you see, these two devices have the inputs here, one here and one here. We'll try to put this device here and here. Let me take this device here and one device somewhere here. Okay. But the main question is these two devices, if I put them side by side, I have to check them. Actually, I have to check these devices. Look, wait 1 second. Let me turn off this boundary. I don't want this boundary. Every time it is creating issue a lot. Where is the boundary, man? Boundary. Okay, PR boundary. Let me switch this one off. Now it will not be selectable. Okay, now if I simply take this device and put it somewhere here, it should be fine, but I have to check that one whether it is okay or not with this one. Whether I am able to put them properly to near to each other, I have to check them. Okay, let me fix this PR boundary to boundary only. Okay, let me fix them with PR boundary to PR boundary itself only. Okay, NVL is there. We have to fix this NVL also. We have to put the layer separately when we'll do the LVS. Okay, so first pin actually, if you see here, sorry, if you go and check this area, so let me go and check this area. If I check this one, this is our first input. You check this one, this should be our second input. So if we draw one input line here, it should be fine. For this one, we have to either take a M4 metal and then we have to do, or we cannot do it directly, or we can put this device directly to this level only. Then it will be direct. Both the connections will be direct in this case. Both are direct in this case actually. Now we have to take this inverter. Simply can take this inverter from here, and we can then like let me take this inverter up till this level, and then we can do it. So if you see,
Sir,
input
one
of this
question.
inverter is going to the, yeah, tell.
Sir,
Yeah.
in this case, if we keep the second NAND gate below the first one, in this
Uh-huh.
case, we have to start the VDD to VSS,
We have to
VDD to
flip them. We have
VDD,
to
and
flip them.
yeah,
We have to flip them. See, it is VDD. Below is
Yes.
VSS. So let me pull it down. So this is VSS. We have to flip this
Yes.
one. This one I haven't flipped it
Okay.
yet. I will flip it later. Actually, we have to flip this one simply like this.
Okay,
Then
sir. So we will press
layer
the
by layer.
yes.
Yes. Then layer by layer, we have to align them. Like first, I will select this guy. I will go up till
Yes.
here and I will align it like this. Then PR boundary to PR boundary, I will do from here. 1 second. From here, what I will do, I will take this one and I will put it here actually. It should get aligned properly with each other. Now, if you see VDD,
Yes.
VSS, VDD. Okay.
Okay, sir.
In this one now, what I will do, I will just align it here and okay, sorry, and I will take this one, I will align them both here. Okay, this all done. Now, if you see here, the input of this here should be connected to the B input of this NAND gate. Okay, this area should be clean for me. So what I can do in that case, either I can pull this device and I can short them exactly from this level. It is much better to do. I can do in that way also. I can do in that way. Like what I can say, I'm trying to say is when I am going here, let me fix this area first. This 0.005 and then 0.005 and fine. What I'm trying to say here is let me pull this guy. It's this. Let me pull this guy up till here. Okay. And let me align this one with this level. Let me do one thing. Let me draw a line. Okay. And from here, I will be aligning this one to this one. Sorry. Okay. Now it is aligned. Both of them are aligned properly. Now, main question is if I draw a metal one, if a metal one is passing from this level, is it actually maintaining that area? I have to check this area actually from here. To check this area, like I have to make it first 0.26. I have to check the distance spacing 0.26. Okay. Now I have to check whether I am getting that level of area or not. It is 0.95. I think we will be getting a spacing error here. At this level, will for sure I can think that I will get an error. Or we can check this one later as well. We can check this LVS thing later. We like DRC thing later. We are getting this area like this or not. Let me do one quick run of the DRC. Immediately, all things are set. Let me run a DRC and let me check whether I'm getting any error at this, well, like this diagonal metal. Like what I'm trying to say is like this metal one to metal one in diagonal DRC is there or not. I have to check that one. Okay. Okay. Okay, it is giving a Mux layout weekend. I think metal one to metal one spacing. It is highlighting like this, but where it is highlighting, let me check that one. If you see here, okay, at some around at this level, it is actually flagging that error. Actually, it is flagging the error at this level because, got it. Because this area is not exactly aligned properly. For that one, what I can do, let me fix it. Let me go at this level. Let me 1 second. Let me close the run actually from here and let me go in this level. Okay. Let me go in this level and try to fix it. Okay. Let me 005. There are multiple fixation you need to do actually when you are doing a layout. 1 second. Who's that one? Excuse me. Okay, let me do this one. Okay, these actually why are happening? Let me first check the spacing between these two. It is 0.15. That is the reason it is actually flagging for me. It can be 1 second. It can be aligned. It can be aligned properly up till this level. This area should have actually a spacing between of 0.2 or 0.12. That's fine. It was actually extending a bit. That is the reason. Actually, I was not getting that area. So this area doesn't have any DRC. So we can use this area to use them. Okay. Let me shift back to the layout, actual layout. Now, if you see, now if I check these two connections here, it is green highlighting color. Colors are highlighting like this. 1 second. Let me make this window a bit bigger. It will be easier for me. So these two are highlighting properly. Okay, let me turn on the navigator once. Okay, so if I click on these two, you will able to see these two are highlighting. Means now what I can do, I can just simply draw a metal two connection layer on the top of this one. Earlier, what happening in this one was at this level. So what to for that one, what I have to do was I would have to for this one the problem. So for not connecting this one, I could have drawn a metal to connection at this level. I would have patched it with a metal to metal one via. It would have connected with this one. That's a fine, not an issue. But the problem would have occurred with this one. This net should have been at this level because this is the input. I am putting this as the input. If the now if the input would have been taken vertically like like planning would have done that this layout we will take it vertically from here directly, then if you keep the input here it's fine. Like vertically we will be taking this one, we will not be taking like, or we will be putting a metal 4 layer on top of this one and we will putting the aligning it here. In that case it is completely acceptable that we do not need to this move this one from here to here. But at this level when we are doing it like this, so we are not, we are trying to not to go to much higher metals like metal 4. Wherever necessary we will go, wherever not necessary we will not go up till that level, because when you are going to more metals, the cost of fabrication increases. So for this much level maximum metal 3 is maximum can be used. For very little case metal 4 maximum. So majority should be maximum, you can do with metal 2 and metal 3 only. So that's the reason I tried to do, I want to draw this metal 2 up till this level, and I want to make it what I can say, I want to make it the connection of the input of this one. Like let me show you. I will just simply draw it up till this level and I will okay, 1 second, that's 0.005 it should be. 5 and 0.005 it should be okay. Now it should be okay. Okay, now let me draw a metal to track over this one and after let me edit it up till this level, and I will simply change to 0.26. Okay, excuse me, 0.26. Now what happens, see, I can put the pin here now at this level. That pin name is I0. Actually that pin name is I0. I can put the pin, it should be working. Okay, now for this guy we need to actually just draw the connections. Yes, who's that?
Sir, there will be a spacing error between metal 2 to metal 2.
I didn't got, can you repeat again?
Sir, there will be a spacing error between metal 2. As we have dragged it, you can see with the pin of the inverter.
Where you want the spacing? This
Sir,
area?
just go to the inverter.
Inverter
Yes.
only.
Yes, sir. You can see, sir, we have drawn the metal 2 layer for the input A, but
Input this
there is
one.
also, yeah. Yes. Does the
From
spacing
this to this
will
spacing you want?
yes, yes, yes.
We
Yes,
can
sir.
check this spacing. We can check this spacing every time. We can check this spacing. See, it is 0.2. It is okay. Spacing is okay, na? So 0.2 is the
Okay.
minimum required above. If the width is above 0.2, 0.2, up till 0.5, then the spacing should be 0.2. If it is
Okay.
above 0.5, then the spacing will increase to the higher spacing will be higher in that case. In that DRM, it is all these things are written properly. If you read that DRM, you will get to know.
Sure, sir.
So these things, these two things, if you see, let me excuse me. Let me do one thing. Let me go over the net connections, simple net connections. These are our devices, right? No, these are our devices. We want for the net connections actually. I0. If I take the I0 connections, like it is telling that I0 here doesn't have that connection. I want to pull that connection to the top. Like up till here, this level, I want this I0 connection. I will just put this I0 at this level because the pin is here. Okay, and I will be putting this I0 connection at this level. I will then simply take this alignment here. We can just fill this area with these pins. Okay. Okay, done. If you now see the I0 guy, it should have been done properly. Okay, I don't know why it is not flagging out actually. I0, it is okay, that's fine. I1, for a case of I1, I1 is actually at below level. Okay, what we can do here is, I1, like, let me take this guy and align this with this level. Okay. Let me align. So I do not need to take any, I do not need to route this layer. It's fine. Let it be like this only. Okay. Let it be like this only. I do not need to touch this one. Or what I can do here is, I can just simply drag this guy from here. And because these two doesn't have a major input connections available. So what we can do here is, to save this space, I can just drag this guy. Okay, I can try dragging this guy. Okay. Let me drag this guy from here to this level. Let me, but we will get DRC error for sure. We will be getting a DRC error at this level. We will get a DRC error at this level for sure. It is for sure. It will get a DRC level at this level. We will be getting a DRC level errors here actually. For this one, what we can do here is, 1 second. Wait, I have a idea for this one. 1 second. Let me go to this guy. Let me go to this guy. Press E and change this to 0.005 and 0.005. And let me do one thing. Let me delete this one and this one. Delete them. Simply delete them. Go to this guy. Parameters. Parameter body type. Make it detached and make the tap on the level. You can do it in this way also. It is like this. Tap body type detached also you can do. You can draw it manually also. I'm not drawing. I'm just making it like this. It is much more easier to do. It will be much more convenient for you guys to do. Okay, done. And simply then put this VDD at this somehow this level. It should be coming at this level somehow. Okay. Okay, now fine. Go to this below guy, query, and then wherever we have now changed, we are now changing these tabs actually. Wherever we have used this block, it will actually change that level also. We have to go and align them properly at that level. The other blocks we have done, it will be hampering those blocks also. That on just alignment you have to change. It should be the alignment only will changing, nothing else. Only the alignment will change. Let me just align it with here. Okay, it should be now fine. Let me align this one with this one. It should be now okay. And for this guy, let me align this one with simply at this level. Okay. And for this one, let me align this guy with this level. Actually, it should be like this. It should be like this here, and it should be like this at this level. It should, okay. It is not aligning only here. It should have aligned properly. It should have been aligned properly at this level. Let it be like this only. Okay, nothing will happen. Okay, this should be okay, and we can save it simply. But here in this case, I should have been aligned this PR boundary to this level. Okay, let me do it. It is much more convenient to use actually. If you go through this one, it will be more convenient to use. 1 second. There is actually a NVL layer actually. you can delete this anvil layer, not required anymore. Actually, it is already aligning here, so this is not required anymore. Okay, you can just let me do one thing. Let me align this. Let me decrease this boundary level. I don't want this much level of boundary. I can just align it with here, and we can decrease the area. I can decrease this area a much. See, this area got shrinked back at very much easy level, and now we can save it, and we will able to change it later at somewhere. Okay, here it is actually not done properly. Okay, it is now done properly here. This should have been done up till this level. So where is our PR boundary? This is our PR boundary actually, right? So at this level, what can we do here is we can just pull it back up till this level. But the problem here will be this via actually better do one thing. Delete this via, delete this guy. We will be seeing this layer at on some different stages. Better make this, change this to this one and delete these metals. I don't want this metal to be now here. I will just go and I will change this to metal 1 pin. Wherever required, we will patch up the wherever required, we will patch up the metal 2 and with a VR. It will be better now. Okay. We will able to do. Okay, that should be fine. And then okay, and we can shift back. We can shift back to that level. Okay, now this should be fine here. I can take it outside. So this is our inverter size now. We have changed this one a bit. Then we can go at this level and also we can just change this guy also. Then the these settings will be easy to do. These settings will be easy to do. Okay, let me do in this one as well. Let me first align this one to 0.005 and then 0.005. Okay. Let me again delete this one. What is that layer? Anvil layer. I don't. We'll see that one. Okay, we'll see that layers thing later. Excuse me. Okay, and then I will be going to this level. This level, press query, common. Common means if you don't take common, only single will be changed. If you take common, both all selected will be changed. Okay. Now we will be doing. Okay. Body type, it is not coming like this. We need to do it like this only. Common query, parameter, body type detached, top tab and close it. You can draw also, and you can what I can say, you can just normally do this way also. Okay, like go to body tab, detached, top tab, untick this one. It should be okay. Now it should be okay. Up till this level, it is okay now. Okay. This should be now. Let me pull this one up till somewhere at this level. It should be okay now. For this guy also, I will go parameter. I will go to below and I will make it as detached. And I will just make it bottom tab and will close this one. It should come like this. And then I will be do query parameter again like this. Like detached, bottom tab and untick this. Automatically taking everything. It will take care of everything. Okay. You do not need to you don't need to worry about anything. Okay. Let me do one thing. Parameter, and that is actually merging actually, right? Detached, bottom tab and close it. Let me do again. Go here. Parameter, body type detached, bottom tab and untick this one and should be fine. Now it should be fine. Okay. It should be fine now. Let me just align it with this level. Okay. Our all things are ready. We are ready to proceed with the next step. in this one. Now what I can do here is, I think our PR boundary is settled down. Wait 1 second. I think one layer is available, right? We can delete this layer. Not required. That layer is not required actually. Yeah, if I see the NVL layer only, okay, that NVL layer is still fine. We do not need it to change anything. We need only these guys to change. This PR boundary I will just take and I will align it with here. And this guy also I will, sorry. These guys also I will take and I will align it with here. It should be aligned properly. If you see this PR boundary right side and left side, it is already aligned properly. Nothing to touch here. The top side also aligned properly. Only the thing is that this devices. Okay, this is fine here. This is also up till this level, this PR boundary only. This is from the top level. We don't have to touch this one. Yeah, who's that one?
Sir, could you,
Yeah, tell.
could you off the option of dimming, sir?
Yeah, what happened?
If you are zooming means it is not visible, sir. It is looking dark screen, the layout.
Dimming, turning off is not good actually. It will hamper you only. Better, you now it is fine.
While
Now it
while
is
you are
fine.
zooming, now it is fine.
You can just decrease the brightness, the dimming intensity. That would be fine. If you turn off dimming, that will be difficult for you only to highlight, you to find the devices. That only I'm trying to say actually. Okay. And as per this one, if you see, the device should be actually at this level. It is fine for this level. But here at this level, it is not actually good. If you see, it is not actually good at this level. For that reason, what I need to do here is I need this whole device set to be increased. I need to hold this device set need to be increased actually at top level. Up till the top level. I think that is not much required. If I just, I don't know why this area is not proper actually. Okay, that PR boundary has the issue. Okay, this is okay. We'll check the PR boundary there. Okay, here it is still fine. We can go to shift back and we can go to these device ones. And I will let me pull PR boundary. Actually, that is the reason it is enlarging that area. Okay, that is increasing this area. That is the reason. Okay. Okay, now it is at same line. Okay, shift B. Okay. Now, if you see our devices are okay now, correctly okay. It is corrected properly now. Okay, now what you can do here is you can just simply use these devices to this level. Let me now I can do, I can go here, align this one with this PR boundary simply. 1 second. I will just simply align this one with this PR boundary simply here. Okay, I will turn off each layer. So every layer I will turn off and I will align this PR boundary to PR boundary. If you see here, only a NVL layer is there. So for that one, what I will be doing, I will be doing that to NVL layer later. So leave it that one. If you see now, it is properly aligned. Here all devices are properly aligned, but the only thing, it is not connected. If you see here, it is not connected. If I delete this one, see, it is not connected here properly. That is the reason. Okay, that is the output. Now let me fix it. Now let me start fixing them. Okay. To fix them, now what I will be doing, I will just simply go to this input line. I will check. So it is properly here. What I will do, I will be take a M2 to, oh, sorry, here I will go here and I will take a M2 to M1 via first. M2 to, so M2 to M1 via and I will change it to this level. Okay, and I will be aligning this one with this one simple. A simple, I will putting a M2 to M1 via. It should be taking care of this one and just draw a M1 on top of this one. Just draw a M1 on top of this one. Now it should be okay. because the M1 coming from below will actually might hamper actually the devices. That is the reason I'm drawing it. Just simply draw it. 0.26 it should be. Okay. Now, if you see here, you will get to know the things actually. If you come below, let me come below I0. This is our I0 guy. It is our I0 guy actually. Okay. Let me change this to M2 pin first. M2 pin. M2 pin here and okay. If I press to M2 pin, you will see able to see that I0, this yellow marker has gone, means our this net is completed. Now for the I1, if I come back below, if you see it is already still left, but it is not done yet. For that one, what I can do here is I can just need to align them properly. It is not aligned. For that one, the reason what I do is I need to tick this one and simply I will align this one to this one. And then what I will be doing, 1 second, I will be just aligning PR boundary to PR boundary simply. PR boundary to PR boundary should be aligned properly, but still we will be getting some, what I can say, some kind of error we might get at this level. We might get at this level some errors. We need to check on those. See, if I'm aligning it like this, we are getting error at this level. Still, it's fine, not an issue. Or we can just align this one at this level only. Better to do it at this level only. It will be much better. So no DRC error will come. Leave this space, nothing will happen. Okay, so if it is aligned properly, they are aligned okay in a correct manner, which is done. And for this one, what we can do here is we can just simply take this area, this guy from here, and I will pull this to come at this level. Okay, we can just pull this one to this level. I will just simply do it one, and I will simply select it. I will change to metal to pin. Click common and metal to pin. Okay, if I see now, if I go and check this one, okay, 1 second, what is this one? Why it is coming? No, I don't want this one. This one should be turned off. Okay, now if you see I1 has been marker gone, I1 now marker gone, I0 marker gone, I1 marker gone. Okay, now net 17 come. Okay, this is the net 17 actually. Okay, and for this one, what's that? It should be connecting. Okay. First, we have to connect this one, this guy. That is net 21. Okay. I will be taking this device from here and I will try to align and keep it here. Okay. And I will be aligning this one at this level. Sorry, I will try to, from the below only. It will be easy to align properly. Okay. See, it is now okay. Now, if I go at this pin connection to create the AND gate, you will see it is actually aligning properly. Simply, what I will be doing, I will be just drawing a metal to track over this one. I will simply draw a metal to track over this one. I will simply draw a metal to track, which is 0.26. Okay, 0.26 I will be drawing on top of this one. If you now go below and try checking that net 90, okay, that not that one, that net 21, it is the yellow marker gone. For the net 20, I need the another device actually also. Okay, I need that another device actually for this guy actually. Okay, for this guy I want. Sorry, like for this guy I want the actual net connection again. I will take this device up till this level and I will but the problem here will be this is VDD, and this is VSS actually. Okay, we have to flip it. If I forgot to flip it actually, if I flip it, still I will be able to do out and in. 1 second, net 21, still net 21 fine. I will be taking this guy and I will be aligning both of them up till VSS and VSS. Okay, who's that one? Font. Okay, I will just implement them here. And what I will be doing, I will just take this guy and I will try implementing at this level. Okay, if you see here, you will able to see these two are required. What I will be doing, I will just simply copy it rather creating again, rather drawing again. I will just simply copy this metal piece and I will just put it at somewhere here. It should be connecting both of them. Okay. Now, if you see, if you come across this one, I0 done, I1 done, net 19 connected from here to here, net 21 connected, net 22 connected. If you see here, net 91, 1 second, better put this track somewhere at this level. It will be much more good looking. Mm, 1 second. Delete it and again draw this one. M1 drawing. Okay. Just simply draw it from here to here only. It will be much better to do. Metal. That is something different came. Metal one drawing. Let me change it and 0.26. Okay. Simply I'm drawing it like this only. Okay. And going to this part, I'm making this metal 22. Like, okay, net 21, that should be net 19 done, net 21 done, net 22 done. Now remaining is net 20. Where is net 20 here? Okay, this is the guy. Okay, I need to change this one as well. These are fine. I need to change this NOR gate actually. Need to change this NOR gate. Let me switch back to L first and then I will fix the grid 0.05 and 0. We change the NOR NAND gate and the inverter. So we didn't change this one actually. We need to change this guy as well. Okay, let me change them actually. And let me go here and non-pattern parameterized. Okay, that I don't want to change. Query parameter. Let me go here, body type detached, and let me make it to left tap and top tap. Okay, it should come like this, and then query parameters wise body tab detached and top tab, turn it off. Okay, for this guy also I will go below here, body tab detached. Okay, bottom tab and done. For this one also I will go here and make body tab detached below and I will make it as bottom tab here, left tab. Okay, done properly up till here. 1 second, give me. Up till here done. Okay, after this one, if you see all the connections are done properly. Okay, let me pull this one at this level. There are some minor changes, nothing else. These are some minor changes, small changes are there. I'm just fixing them so that the layout should be fixed. I could have done it in the other blocks also, but I did it that way only. So, okay, not an issue. We can do here at this level also, this way also. It's still fine. PR boundary and then okay, I cannot take this guy and pull it somewhere here. If I do that one, then it will be a issue M2 to M1. Actually, if I do here like this, okay, the spacing issue will be there. Okay, the spacing issue will be there in that case. do one thing better. We can do one thing only for a single piece metal. Just rotate it simply. It should be better. Actually, we should not do this one. Okay, but there is nothing option there. It will give a DRC. Either we have to leave this one, but we cannot leave this one. Then it will be a major. See here, no way is there. We cannot flip. If we flip, it will go that side. So better to do it in this way only. Better do it in this fashion only. It is much better to do. It is much better to do in this way only. So only here the issue is there, or we can do it also. Not an issue. That is, we will just need to fix this PR boundary up till here. That's fine. We can do in this way also. Not a big issue. We can do it in this way fashion also. That's still good. Not a big issue to do. Okay. Let me just pull it here. Sorry, and let me pull it up till here. Then I will put it up somewhere around up till this level. Okay, and let me do one thing. Let me take this guy up till here and let me put this one inside of this one. Actually creating an issue. Okay. Up till here, if I see it is done properly, this this side I know. Okay, below also. What is the issue is, okay, I need, okay, I just need to pull this one up till here, and top side also, I just need this guy to align with this one. This should be fine now. Okay, then save and shift B. If I shift back this level, okay, and then I can just align it with this one simply. Let me align both of them with each other. We will draw the layers later. Okay, we'll draw the layers later. Now, if I come back here, you will see net 22, net 21, net 20. So net 20 is here. It is connected. Just let me draw a piece of metal on top of this one. Let me draw a piece of metal on top of this one. Use like 1 second. Let me draw a metal on top of this one simply. It will be much more now good to metal to drawing. And let me draw a metal on top of this one. Okay, and let me make it as 0.26. 26. Simple, done. And let me just come below somewhere here. Metal 20. See, metal this all done. Now we have to connect these both. I have to take this both guy here, and I will be taking this up till this level. I'll be taking this up till this level somewhere here. Okay, now main thing is, like, main thing is actually we have to connect them. Give me 1 second. Please give me 1 second. Hello. Sorry for the delay. Okay. Now let me do one thing. Let me okay. Let me hold this guy and align this one up till this level, and then I will simply align both of these boundaries. PR boundary to PR boundary done. Simply up till this level done. Now let me check this one if it is done properly or not. Okay, this boundary is not aligned here. It should have been aligned up till this level. It should have come at this level somewhere. Okay, you would have come at this level somewhere. If I now turn off each layer, I will able to see the boundaries. Let's see, there is no spacing between the boundaries actually. There is a no spacing between on the boundaries. All the layers are actually that boundaries are aligning with each other. If you see the boundaries are aligning with each other, this should be an ideal scenario. Okay, this should. But actually, we are supposing to put this block up till here, but I don't know why just we would have get the DRC error. That is the reason I have to put this block somewhere at this level. Either if I would have put this some space available at this area. So no issue. We'll see. No, that's not a big thing. That if you come at this level, you will able to see these two nets are connected properly. The remaining nets are these guys. These guys are the remaining nets actually. Okay. These are the remaining nets which are not being connected. 18 and this guy. Okay, so to do one thing, we can just put for first, let me do this one. Let me just put this metal to track over this one. To track over this one and align this one with this one. Once okay, and take this guy point 0.26 and sorry and okay, and let me put a via M2 to M1 via simple a via should be here. Okay, let me put a via. It should go fine now. If you see here, net 18. Okay, okay, okay. A metal one is required because this pin is not connected. Na? It will see. It will of course. It will pass your it will pass the LVC if you don't draw this metal. But still, why to extraction? The extraction will not pass. It should pass the extraction as well. Just simply draw it. It should now go. It should go now. If you come at this one, it should go. See, all gone. Only this one is left. To connect this one, either I can draw a metal 3 from this level only. Okay, I can draw a metal 3 from this track.
So the screen is
Only
not
I
running.
can. Uh-huh.
Hello.
Hello.
Yeah, your screen is not running. It is.
Unable to see the screen.
Yeah, screen is not running actually. It is stuck in my side, your side.
Is it now visible?
Not visible,
No.
sir.
Still not visible.
Your voice is also breaking.
Like what is it is showing?
It's just blank screen.
1
It's
second. Give me
empty.
1 second.
It's a black screen only.
1 second. 1 second. Might be 1 second, please.
Okay, he's gone.
Is it now okay? Is it now okay?
No, sir, still not
Hello.
visible. Yeah, it's visible now.
1 second.
Now it's good.
Now let me reshare again. Now is it fine? Able to see?
Yeah.
Hello.
Yes,
Okay.
yes.
Yes, yes.
Yeah, yes.
Okay. Okay. Now let me change it to 0.26. 0.26 this one. And let me do one thing. Here via M3 is there here, M1 is there. What I will do here, I will be using a stack via simply. M1 to M3 via I will be doing I will be doing one thing. I will be doing, sorry, not that one. Okay, let me decrease this one and rotate it. And let me put it here. Nothing will happen. Okay, it is actually putting the vias here. Then we can draw the M3 is up till this level. Then we can just simply M1 to M3 is there. I have drawn a M1 to M3 from here. Simply, I will draw the metal to track over this area. This area, I will draw a metal to track. And I will patch it with only metal 2 to metal 3 via. Nothing else. To 6, and I'll patch this one with option metal 2 to metal 3. M3 to M2 via, and I will patch it here. Simply, I will put it at this level. If I put it at this level, if you see, it should pass the extraction actually. It should have now completed. Okay, everything is completed. Net 17 also it is connected. Okay, now comes the S option, that this guy, select line. For them, actually, what I will be doing, I will be taking a metal 3 for this one. I will simply copy this metal 3 only. I will take it up till this level. And simply what I will do, I will just connect this one at this level. Like, is it like something different? Yes. Okay. And then I will be drawing the metal to track over this area. Metal to track over this area simply. Or I will, what I can do here is, no, I only, if I draw it straight also, it will not work. If I draw it from this level also, it will touch this level and it will not work properly. So better to do it at this level only. This way it's a much better way to do. Okay. Okay. And let me change this to 0.26. 26. Okay. And let me align this to align this one. And then I will be putting M2 to M3. M3 to M2 via on top of this one. Okay. To the M2 via on top of this one. It should be connected now. Let me drag this one up till here. And then I will putting again a M2 to M3 via. It should connect this level also. Okay, when I do this one, you will able to see the. Okay, this is left. Okay, right. Let me take this one, and I'm putting everything in this only. Let me put it somewhere on this level only. And let me take it up till this level, and let me change it to, let me change it to common and a M2 pin. M2 pin. Simple. Done. See the S option, it also gone. Now the VDD connections are left. These VDD connections should be connected up till this level. To connect them, first I have to do here is I have to draw the metal 1 connections. I have to draw the like Y. Where is the Y connection? This should be connected at this somehow at this level. This should have been connected at this level because it is in metal 1, leave it at metal 1 only. Leave it at metal 1 only. Simple. Y also done. VDD and VSS required to connected. Okay, now what I will be doing, I have to draw these tracks actually. I will draw these tracks. Like I will be going here and I will be drawing it the tracks actually. Let me draw it from here only. And I will end it up with here at this level. Okay. And I will change it to point. I think that's the area, what the area it is holding. Let me check the area value once. What is the area it is holding actually? 0.12, that is right. That is 0.12. No? Okay, it is done. It is done here. Then I will be drawing the track from here as well. Metal 1 drawing the track from here as well to this level also. I will be taking this, then again I will draw a track from this level also. Okay. Let me do it from here only. Okay. It should be running the track up till this level. If I all this done, so now what I will be doing, I will be drawing a metal 3 track from this level first. One, what I will do, I will take this metal 3 track from here and okay, let's draw it from here only. Why to touch that area? Let me draw it from somewhere here only. Okay. And put it somewhere here. And change this one to some bit of higher length. Make it, sorry, make it to 0.26 only, still fine. 0.26 still fine. Okay, make it 0.26. Okay. I think there is no other metal except this NV. Let me make it so other metal is not available here. So still fine. Take one here. Like we need at least 2 to 3 guys available. Okay, 1 and 2. So metal 3 is already there. So what I will be doing, I will be copying this guy one more time and I will putting it somewhere at this level. Okay, I will putting this one at somewhere at this level only. Okay, I will putting this one at somewhere at this level. So 2 tracks are fine for this one. Okay. And what I will be doing, I will be taking, excuse me, I will be taking stack again, M1 to M3 metal, and I will be putting this one at somewhere at this level. Okay, now it should be okay for us to go. Okay. One here, and one should be at this level. One should be at this level actually. Or what I can do here is let me take this guy and align them to here at this level. It should be much better. It will be easy for me to 1 second up till here. Okay, what the distance it is holding 0.01. Let me check this distance also. It should be also holding 0.01. Just put it somewhere here. Okay, it should be fine now. Just make it like this and align it properly with this one. Okay. Okay, both of them aligned. Now here we need here also. We need it here also. One here and one at this level and one at this level also. Okay, done. Both of them done. Now the VSS is, I think, left. I think VDD is done. Okay, we need this kind of track here and this guy should be going at this level. Okay, now let me take this VDD guy and put somewhere at this level. Okay, let me just put it at somewhere at this level. Okay, and it should be now done. We done. VSS is left. For VSS, nothing to do. Just put this VSS thing. VSS requirement is not there to connect them. Just put them up till this level. Just put them up till this level somewhere here. It should go. That see all the yellow markers of what these nets have gone. Now means your connection is completely done. Just go here. Just now pull this PR boundary back to this level. Now align this PR boundary to this one. Take this PR boundary and align and put it here. It should be done for this case also. PR boundary, what you can do here is, okay, up till this level only we have, so better do one thing, take this, take this metal and align it with here. I think that should be much better in that case. Done. We will able to save this space. Yeah, tell.
Sir, for metal one, how much space, how much width should be there, sir?
So normally it is, see, normally if you draw in this 90, it changes upon the 98 PDK actually. Technology to technology, it will change. For that one, you have to read the DRM. In the DRM, it should be written. So for this 90 nanometer, if you draw it normally, you will be getting, I think 0.12 is the minimum width you need to maintain for the metal one. For the metal one, you have to maintain minimum width of 0.12. Okay.
But sometime we are using 0.26 also, no, sir.
That is the reason. There is a reason why. Now, if I tell you, I am drawing a metal one width like this. Now I am putting a via. Okay, like we are putting a via M2 to, sorry, M2 to M1. The via enclosure size is much more higher than this one. If you see, this width is 0.26. That is the reason we are using that number of thickness. Now got it, Arshad?
Yeah, yes, sir.
Hello?
Yes, sir. I got.
Move
Yes, sir, I got.
origin now. Okay, great. Okay, let me move it to origin. Okay, after here, when you come here, it is done. Now, some things will be left out. Like, let me tell you, this NVEL things, I think this NVEL will be left out. So I think NVELs are connected. No need to draw the NVEL guys again and again. We don't need to touch them. Actually, these are actually, no, somewhere it is left. So do one thing, just go here, simply draw a NVEL layer on top of this one and leave it up till this level. Okay. If you see here, now the NVELs are drawn properly. Now, if you go to the oxide layer, if you go, you need to connect the oxides as well. You need to connect the oxide as well. For that one, what you need to do here is do it separately. Don't connect everything like an NVEL. It is a different scenario. It will come. Okay, just draw it up till this level. Simple. Then for this level also, I think we need to touch the oxide also. I don't know what is the minimum requirement value for the oxide level. I think it should be fine. Oxide do not need this one. I think oxide is still fine. Do not touch the oxide. Just for this guys, draw it. Okay, for this guy, draw it, the oxides. One done. And for this one also, do it. This one also, just do it. I think error will not come. If you don't draw the oxide also, still error will not come. I think so. But still we are doing, nothing will happen. If error come, we will remove it. Okay, the implant as well. Okay, first do one thing, don't draw it. We'll see it later. We'll see that one later actually. But here, as per this area, implants are being shared. Actually, implants are sharing with each other. But here it is not. Let me draw the implant again. Let me draw these implants. Draw the implant. Let me draw it up till this level. Implants are drawn. Here also implant is sharing with each other. No need to touch, sharing. Here it is done properly. Okay, now P implant. Let me go to P implant once. Let me check the P implant. Let me turn off the oxides. Let me accept this one. I don't want anything. I will be drawing. Sorry, N implant drawn. I want the P implant now. Okay, I want the P implant. Okay, here it is not there. Let me draw it from here. Let me draw this one simply up till this level. Done. P implant done. And here also P implant is sharing with each other. Okay, it is sharing with each other. I don't think so it's required. If it's required, we will be able to draw it again. I think the area is higher, much higher in these cases. Okay, Let me go and run the Ashura DRC once. I think up till here it is done. Let me run the Ashura. Run DRC. Okay, let me run the DRC here. Let me run it. Okay, some kind of DRCs are there, like N-well to N-well spacing between different potentials. Valid one. Like, what's that one? Let me check. VDD, that's fine. That is fine for VDD. This VSS, this is fine. Then what is the issue here? Why it is telling that different potential? Let me check the schematic once. Okay, this is connected to this one only. This is connected to this one only. So what is the issue then? Remove all. Okay, let me check this one once. Okay, so this is getting VDD. That's fine. VDD, 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 VDD. And this is getting VSS. All three, all three, all two. Then what is the issue of this substrate problem? Why it is giving this substrate error, like different potential? It is not even in different potential, right? VDD here done, VDD here done, and this kind of VDD here. Simple. Then why it is giving this potential error to me? Like 1 second. Let me close this run actually. Okay, there is a spacing between this. There's a spacing. I left us some spacing there actually. I am by mistake. I and see that one. That is the reason it is giving. Okay. Now let me go to Ashura, run DRC, and okay, it should be now. Okay. Should be now okay now. See, majority of the error gone. Now let me, I think contact issue is there. Okay, let me go and check where the contact issue coming. Okay, here it is coming actually. I think that is really the metal 3 connections. Okay, at this level, right? At this level only. Okay, actually it is coming from the low level. So do not need to worry for that one, I think so. I think so. If you don't need to worry about that one, we need to fix this from the below level. So actually it is coming over the NAND gate. So the NOR gate is fine. NOR gate doesn't have that issue. NOR gate C, it is equivalent in every side. Only in this one, what happened might be some due to some issue. Might be the placement issue. I think so. It is not aligned. See, if you see it is not aligned, that is the reason the contact error is there. This at this spacing. If you see this spacing, it is somewhere between 0.165. And here, if you read this one, it is 0.12. We can fix it. That's not a majority thing. We can fix that one. So let me check this guy now. This metal one. Where is this metal one spacing coming? Here and here. Okay, due to this VI actually it is coming, right? This is this VI, it is coming here. Okay, due to this VI, let me do one thing. Delete it. Delete this VI, M2 to M1 VI, and let me rotate and put it here. Okay, that would be better. Let me rotate it simply. And let me go here. Okay, and check this one. Okay. Excuse me. Okay, actually, I think we didn't check that one. I think, sorry, I think this error is coming from this level. 0.12 it should be. It should be 0.12. 0.12 micrometer. This area should be. Okay. And let me shift B here and let me come here and let me align it with this level simply. Simply I will do it with this level. Again, where the inverters are required. Okay, inverters are not required. It's one only in the NOR gate only it was. Otherwise, otherwhere it is fine. Only the NOR gate it was only flagging. That's fine, no issue. Okay, not an issue for this one. We can run the Ashura again. Ashura DRC. If we run the Ashura DRC once, it should go fine now. See, only except that error, other things are fine. If we go inside that level and try to fix it, it should go. If we go inside this level and try to fix this guy, it should go actually. Okay, it should go 1005 and then 0.005 actually. Okay, it should go actually. It should not be there. I don't know why it is like this. It should have been up till this level only. Then it would have become no. No. How many did 1, 2, 3, 4, 5, 6, 7? 7 devices are there. So in this one, 2, 3, 4, 5, 6, 7 are there only. Then what is the issue here? Now it is being connected. Let me check. Okay. I think that error we are getting still right. We're still getting that error. We are still getting that error actually. If you see, let me go to parameter, tap extension detached, make it none. I don't want it anymore. Let me regenerate. There might be some issue was there and make it none. Okay. Okay. Just let me first go to layout XL. Then I will see. Okay. And let me go to detached none, and this should be none. Okay. Detached none here. Okay. Now let me regenerate again. Body tie detached. It should be top tap. Okay. Query. Body tie detached, and you can make it top tap. Okay. Now I think so it is fine. Now see, it is okay. It's looking fine now. Now for this guy also, I need to touch this one. I need to check this. Or this is okay, right? For n-type, it is okay. That's okay now. I think so. We can go back there in that level. Okay. I think that is okay. Okay. Now let me run the Asura. I think DRC should go now. DRC should go now. Okay. Run the Asura. See, no DRC error. This block is completely DRC free. There's no DRC error in this block. Now, if the DRC is clean, we can check the LVS ones, if the LVS are fine for this one or not. We check the LVS ones. See, this device is completely LVS free also. There is no LVS error in this one. If you see here, Let me come this one. I think schematic and layout match. No extraction warning nor errors were detected. See, this block is LVS and DRC free. There is no LVS and DRC in this block. This is completely clean block. Okay. So this is the last layout we did for the this module 1. We will now go to module 2 from next class. That is our what I can say, that is our CMOS fabrication. Okay, this much layout I did. I hope this is much more sufficient to get familiar with the tool. You just guys need to watch the videos, practice as much as possible, and ask me. Okay. Okay, now you guys can ask me question if there is any question available for you guys. Okay. Hello. 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 Am I audible?
Yes, sir, you are audible.
Sir,
Yeah, ask. Hello. Ask question.
sir, I have one doubt, sir.
Yeah, you can ask.
Sir, in schematic, you have given all devices to VDD and VSS, sir, directly.
Mm-hmm.
Instead of we can give for each device VDD, VDD and VSS, sir.
That pin, right?
Sir.
We can do that one also. We can put that one also. That is actually done in the thing, but it will take time to put those things. It will take time. That is much more. What happen if you do it that fashion? It is much more like efficient looking. The things will be more clean in that case. So it will take time. That's the reason I didn't did that one in that way. It will take more time actually for me. So I have a time issue. That's the reason I didn't did it like that way. Okay.
Sir, what kind of layouts will be making in industry and usually how long it takes?
See, generally depends upon the layout. If it's a bigger block, then like if it's a BGR or a LDO, then LDO can go up till 1.5 month and 2 months or more. It can go depends upon the technology node. BGR can take up till a month maximum a month it can take. So it depends how much
Yeah.
because it's a full chip, so full chip can go up till 2 years also, 3 years also. Like in 1 year also it can end. So like this kind of scenario test comes in the industry. It depends upon the complexity, how big the layout is. Okay.
It's pretty big process then.
What happened?
It's pretty big process.
Yeah, it's a big see. There are multiple. So on a full chip, there will be multiple, like more than 50 guys will be working. Like 10 guys will be from the verification, 10 guys from the analog circuit design, 10 guys from PD, 10 guys for analog layout, 10 guys will be for the chip packaging and interconnects. Like a big team will be working. Like 50 guys will be working. That's a huge team to work. You only need to work for your layout part.
Okay.
Got it now?
Yeah.
Okay, everyone, we can end the session here and we can proceed
Sir.
to end the session. Yeah, tell.
Yeah, one small also. Sir,
Yeah, tell.
why you have removed the what tabs, sir?